Hey everybody, welcome to 8.6. Today we're going to be talking about two unique laws in trig, and they are called the law of sines and law of cosines. So just as a reminder, up until now we've been working strictly with right triangles, and we've used Pythagorean theorem, we've used SOHCAHTOA, and we've used some special right triangle rules. But now we're going to be starting to deal with triangles that aren't right triangles, and this is where these two different laws come in. So the law of sines I have written here. Notice that I have a non-right triangle picture below, and the law of sines is simply just a bunch of fractions set equal to each other. So basically it's just proportions. So you'd have the sine of A over little a equals sine of B over little b, and then sine of C over little c. And I went ahead and put off to the side here a couple important notes. All the capital letters, A, B, and C, those refer to the angles of the triangle. And then little a, little b, and little c refer to the sides. And I went ahead and labeled in blue on this picture how we can find A, B, and C when they're little. So the trick is the side A is across from angle A, and side B is straight across from angle B, and same for C. So you always know that A and little a are going to be opposites of each other. Okay, so the one unique thing about law of sines is even though we have three fractions here, when you're actually using the law of sines, you're only going to ever use two at a time because you want to think of it as a proportion. So you only want two things so that you can cross multiply. All right, now when we're wanting to use the law of sines, there's basically three cases where we could use law of sines. The first is our angle, side triangles, okay, or we can have angle, side, angle, and those should be familiar from last semester when we talked about different measurements within a triangle. The other one, which we did not use last semester, was the side angle, and so now we're going to be talking about how we can use that to solve if we're given law of sines. Now, you won't see that very often, but just know that it's a possibility. And instead of necessarily memorizing these three different cases, I tend to find that the easiest approach to identifying the law of sines is to make a table of all your data. So in this example right here, I've got triangle A, B, and C. And the directions for this one would say solve for x. So what I'm going to do each time is I'm going to make a little table of all my information. So I'm going to write angle A, B, and C, and then I'm going to write little a, little b, and little c. And I'm just going to go ahead and fill in what information I know. Well, I know angle A is 78 degrees, and I know little a, which is across from it, is 8. And then I also know that angle B is 60 degrees, and I'm looking for little b, which is the x they have there. Now notice I don't have anything for row C, so I really don't need it in this case because remember we're only going to use two sets of letters at a time. So I'm just going to kind of ignore the third row for now. Now later you're going to want it, but for now when we're just starting off we don't really need it. So the trick to being able to tell if law of sines is going to work is to look at your table and see if you have a full row of information. So if we look here, I have a full row of all the A's, which means I am good to use the law of sines. And you'll see later in our other examples where you may not have a full row, and so you might run into some trouble. So because I know I can use law of sines because I have a full row, now I can just go ahead and plug in my proportion. So remember our proportion said the sine of the angle A, so sine of 78, over its side, so 8, has to be equal to the sine of angle B, which we just said was 60, over little b, which is the x. And now this is just a nice proportion that we could go ahead and solve by cross multiplying. So if I cross multiply, I get x times the sine of 78 equals 8 times the sine of 60. Now there's a couple different approaches that I would take in this. If you have a scientific calculator, what I would suggest doing is typing everything in all at once using some parentheses. But if you're not comfortable with your calculator, you're not sure how to do that, or maybe you have a really basic calculator to start, then you might have to change all of these answers to decimals. So I'm going to go ahead and do that just to show you what it would look like. So if I want to set everything or plug everything all at once, I'm going to go ahead and divide everything by sine of 78. And I'm doing that because I want my x's to be on their own. So I'm going to get x equals this whole fraction, 8 sine of 60 divided by sine of 78. And then what I would do is just go to my calculator and I would type in the top and then divide it by the bottom, and I would get my answer. And you should get, let's see, 8 sine of 60. Make sure your calculator is in degrees. Okay, divided by a sine of 78, you're going to get roughly 7.08. Now, if you don't know how to do that, or like I said, if you have trouble typing in your calculator, you can always go back and change everything to decimal. So I'm just rewriting this with decimal answers. So in your calculator, you could take 8 sine of 60. That's going to get you 6.9282. And then sine of 78 is going to get you 0.9781. So x times 0.9781. And then I can just divide both sides by that decimal. So here we're just dealing with a rounded version and then typing these numbers into our calculator. So it will get you the same thing. It's just two different ways of looking at it. If you do have to convert them to decimals, make sure you leave more decimal places at the beginning. That way your answer is more accurate at the end. Okay, so we found that x was 7.08, so that was our missing side length. Now, also keep in mind that you are dealing with sides and angles of triangles, so you don't want to get a negative answer for your solution. So if you do get x equals -5, then you need to rethink about how you set up your equation or how you solved, because obviously you don't want to have negative side lengths in these problems. So let's go ahead and take a look at example 2 in this case. I'm going to go ahead and set up my table to start, and just keep in mind I have Q, R, and S, but they don't have to, it's the same concept. It doesn't have to always be A, B, and C. Okay, so I'm going to set up Q, R, and S. And remember, the goal is to see if I have a full row of information. So I'm going to fill in what I know from my picture. So in my picture, I know angle Q is 37, and I know that angle S is 54 degrees. And I know little s is the x, okay, so it's across from it. And I know little r, because it's across from angle r, is 10. But right now I don't have a full row, so that's a problem. But can I find a full row? So you want to always think about that. Well, the only other thing I'm really missing that would get me a full row is angle r. Well, could I find angle r by doing a quick calculation? Well, the good thing is these are triangles, and we should know that angles in a triangle add up to 180. So if I take 180 minus 37 and minus 54, then I can find that third angle measure. And then I would have a full row ready to go. So this gets us 89 degrees. So angle r is 89. And now, because I was able to find that full row, or that third angle, I now have a full row of information, which means I can use the law of sines. Now, because I'm looking for little s, I also want to use this information instead of the row Q. So I'm just going to ignore Q for a minute, okay, and then later if I needed to find something else, I'd go back to it. And now I just go ahead and fill into my proportion. So I'm going to say sine of angle R, so 89, over its side is 10, equals the sine of angle 54, angle S, over x. And now we can go ahead and cross multiply just like we did in the last example. So I want you guys to go ahead and try to cross multiply this one and then tell me what you get for your answer for this missing side length.